So I'll get started with just 5 minutes of background and information about our lecture series, and then I'll introduce our speaker for today's BSEE. So welcome all. This is the lecture series hosted by the Integrated Design Lab. We're a research branch at the University of Idaho, part of the College of Art and Architecture. We've got a mix of architects and engineers here. A couple new graduate students that I'm really happy to have on board. But we're all about education and outreach, and we're all grant supported. So some of this funding and this lecture in particular is coming thanks to the support from Idaho Power. I can advance my slides. There we go. Who also provides funding for our lab to do technical design assistance. There's more of this available on our website. Won't go into too much detail because many of you may be familiar with it. Know that we're not trying to compete with private industry or offering discounted consulting services. What these are discounted educational services so that we can encourage your firm to adopt best practices, tell you about emerging technologies, anything up to $4,000 worth of our time, and we're cheap for grad students and professors, is totally free to you and covered by Idaho Power. A larger project, Idaho Power will do a 75% cost share. And that allows us to help train you on energy modeling tools, audits, things like that. We also offer this lecture series, BSEE. So thanks for attending today. Our next one will be on indoor air quality and energy efficiency with COVID, with Elizabeth Cooper, our previous director, talking about her PhD that she's wrapping up right now, actually, at University College London, specifically on this topic, so very timely. Also come by our lab if you want to check out some tools, diagnose how your building's doing. These are completely free to anybody in Idaho Power service territory. So we've got, things to check your envelope, your light, your flow meters. Some new tools we've got, some physics classes if you need to do virtual walkthroughs, you can send them to somebody. New flow hood, which is great, and ozone monitors, things like that. Everybody's really focused on indoor air quality, so we've got some new tools that can help you with that. If you're not sure which tool you need, talk to us and we can help you out and show you how to use it. Idaho Power also independently offers new construction and major renovation, energy efficiency, resources and rebates. So check out their website, shown here, idahopower.com/business. They've also got a custom efficiency package, and their professional assistants. There's kind of some new guidelines out there, new rollout June 15th, including increased incentives up to $5,000 per project. So check those out. All right. With that, I'm going to stop sharing and introduce our speaker today so that Joe can start sharing his screen. It's really my pleasure today to welcome Joe Herbst. Joe is leading a team that's developed an advanced Internet of Things platform for over 200 products, really on the backbone of Power over Ethernet. He's an entrepreneurial executive who holds 16 patents and has founded over 4 startups. Joe has a bachelor's in electrical engineering from University of Delaware, a master's in electrical engineering from Purdue, and an MBA from Santa Clara University, just to round things out. So Joe's worked in several transformative industries over his 30-year career, and I'm excited to hear what he has to share with us today about new lighting platforms through Power over Ethernet. So Joe, thank you for your time, and it sounds like you'll be handling questions kind of as they come in. We've got about 15 or so participants on there, so people can unmute themselves, but there might also be some pauses along the way. And then Jason Telford, our grad student, will also be monitoring the chat. So Joe, thank you again.
Perfect. Thank you. I appreciate the introduction. To everyone out there, I'll stop several points through and ask questions, but I also know sometimes you just want to kind of get it in the chat box to, not lose the thought. So either way works for me. I encourage interaction. What I'd like to talk to you today about is Power over Ethernet, and specifically how it is coming into buildings, building automation, and lighting specifically, and that's kind of where it's made a transformational change. Kind of just quick objectives I want to go, this is going to be a little bit technical later on. I don't expect everyone to fully grasp everything, but more just kind of lay the groundwork of scope. So I'll go through kind of a lighting control takeoff, and ultimately I just want you to have a sense of, you know, what you need to do lighting and building automation with Power over Ethernet, and then what questions to ask. So let me start. I don't know y'all's background, but just I'm going to quickly go into like what is PoE. PoE is Power over Ethernet. It's an 18-year-old technology. You're probably most familiar with it with the desk on your phone from years ago. Essentially, the technology brings power and data over one category cable, historically Cat5, now Cat6. What's transformed and changed lately in the last year or two is that it now supports up to 90 watts, which brings the whole world of lighting with, you know, essentially the efficiencies brought by LED manufacturers now into play. So essentially the thesis that we're working towards is everything above the desktop can now go low voltage. Still going to need AC, not refuting that, but essentially everything above the countertop desktop, including desktop charging, phone charging, lighting, cameras, tablets, and whatnot can all be essentially low voltage. There's a number of benefits to that. If you walk away with nothing else, the why PoE and PoE lighting in a building, the four things I always talk about: 60, 100, 130, 60% less copper, essentially going from 12 gauge wire down to 18 gauge wire, or even 23 gauge wire in most cases. 100% less steel. You no longer need conduit. So for the architects in the audience, that is great if you want to do an open ceiling design or a retrofit of an existing place. It's 100% more resilient to change. So we've had a number of projects where they, you know, we had the one I'm going to go through, they wanted to add a pharmacy. So it's a medical facility, and they wanted to add a pharmacy. The change request was $30,000 quoted from the electrician to do it in high voltage. It was literally no cost from the low voltage because all they had to do was change 3 cables. So because now a lot of the behavior and capabilities are done in software, the cost to make change requests is, you know, virtually zero. And then 30% lower operating costs. Essentially, you're not converting AC to DC in every light bulb and light fixture. PoE also brings tremendous number of new features, so we can tie together things that you didn't historically tie together. An example: a people counter counts 6 people go into a conference room. You can now proactively tell the HVAC system to increase circulation. You can look at not just one temperature sensor, but multiple temperature sensors, and you are essentially bringing together information in a meaningful way and acting upon it in a much more efficient way. PoE also now, it unifies MEP, mechanical, electrical, plumbing, but it also kind of disrupts the classic model. So if you look at building construction, you've got your historic Division 23, 24, 25, 26, 27. But with PoE, we actually now have lighting being bid in either 25, 27, or 28 as a low voltage entity. IoT kind of disrupts this whole thing anyhow, just because the sensor data is essentially going to be prolific throughout the building. And all of these historically vertical structures are now going to be tied together in ways that make the building much more efficient and much more flexible. So I'm going to take you quickly through an application example, and I just want to highlight, if you're not familiar with lighting and lighting design and the context and building automation, I just want to give you an example of how different a single room can look. So I'm going to take just the conference room, for example. So in this conference room, I've got PoE shades, I've got daylight sensors, occupancy sensors, I've got a cove light and a suspended pendant linear. So how does the designer look at this room? Well, I've got window treatment, I've got a Type B downlight, a Type A dimmable luminaire, I've got a CCT tunable up-down linear pendant hanging over the table, and I've got a RGBW cove light. So that's how the designer sees it. How does the energy code official see it? Well, they see this as I've got a daylight zone, I've got a non-daylight zone, I've got an occupancy zone, and I've got an emergency fixture. So completely different perspective on the exact same room. A third perspective is how do the users see this? Well, the user wants to be able to control this group of lights in one way, a different group in a different way, but essentially they're going to have the clusters and groups of these lights that essentially are going to be controlled through schedules or button presses or scenes. So those are three completely different examples. This is where PoE has tremendous advantages over a high voltage system. So to do this in a traditional way, you would have to have a DMX backbone throughout this. It would be extraordinarily expensive. With a PoE system, you essentially just have 5 drivers, PoE drivers, that's what that link is, an 8-port network switch that can tie into your building, and then one essentially server that manages all of these different requesters. So you can have a daylight sensor that adjusts just the lights in the daylight zone, an occupancy sensor that just controls lights in the occupancy zone, and then ultimately a wall station that gives the users their preference. So any questions on that? Does that make sense or give you some insight in terms of lighting and the world of lighting? I was just going to stop here if there's any questions. People can jump in. Okay. So let me talk about a little bit of some of the networking gear and software that goes into this. So at the edge, and edge is like what would be right next to a light fixture or a door magnetic lock or some other edge device. So we have essentially a gateway host, which in this instance we have a Linux server that is PoE powered and essentially manages an area. It can manage an entire building, it's just more a sense of scope. And then the node. Node is a driver in the traditional world. An AC driver essentially takes AC power in and then essentially controls LED plus and minus. This is an example of a device that does that for up to 4 fixtures and then can either do it as a constant current or a constant voltage model. And it also accepts inputs. So inputs can be occupancy sensors or wall switches or daylight sensors. We also have kind of the core power and data gear system, maybe something that sits in the IT closet or IDF closet. So an 8-port or a 24-port network switch, PoE switch, and then some kind of power supply or connection to the power source. Physically, all of these get connected together with Cat6 cables, so you can have not just lighting, you can also have shades, you can have IP cameras, HVAC integration, sensors, occupancy, and wall switches, and essentially they all are connected physically to a network switch, and then after that, software just takes over. So software will assign something as an input stimulus of a given type, temperature, momentary button press, a web button call, a light level sensor, a CO2 sensor. So those are all input stimulus. And then the corresponding output side of that would be like a fixture. Maybe it's a light fixture that goes warm at 50% or cool at 75%, or an RGBW fixture. It could also be a mag lock or any other type of output device. So the software is what glues these together and essentially does that through what I call a if this then that engine. And so I can, for example, have one key card access be able to do a multitude of actions. So this is an example of one where I just have a door access and essentially I go through, and this sequence is exactly what you're seeing. Essentially you turn the lights green, wait, red, and then off. So that's just an example of what we take as a stimulus, which is just an RFID on an access control, and in this instance just turn the lights red and green. We also have schedulers, so stimulus can not just be, like a physical button, it can also be a time event or a virtual web button that we tie in from the cloud. So any questions on that? Okay. So let me run through a takeoff. So takeoff is essentially where you are taking a reflected ceiling plan and creating a bill of materials. So tools required. So I use Bluebeam Review. It's not the only tool that's out there, but I'm just using that as an example. It can be AutoCAD. Ideally, you want to get something that has counts that can do essentially a count of all of the items. I like to use Microsoft Excel or Google Sheets in terms of doing a load calculation, and then I often recommend a large monitor or scroll button mouse. So examples of information you're going to need. You're going to need a light fixture schedule for the project and the characteristics of each of those fixtures. So the spec sheets are the best source of that. You want to make sure that the fixtures are PoE capable. If they're not, if you remove the AC driver and bypass and directly connect to the PoE driver, you've got about a 98% chance of full compatibility. I always recommend test before you install, but that's a general idea of intentionally what the PoE driver does is essentially replaces the AC driver. And then look at constant voltage versus constant current. And then what is the controls intention? Is this a California 1024? Is this an ASHRAE project? Is it just user-driven? So incorporating all of those into the software. So the lighting fixture schedule, essentially, I have created an Excel spreadsheet. I'm happy to share this with anyone. But essentially, the reason why I did it in Excel was, you know, if you're going to change fixtures or change types, I typically want to have something that's dynamic. So I create this Excel spreadsheet that has the fixture schedule in it and has the basic information. And then this will essentially roll up to a power calculation. So I have power for each fixture, and then essentially from the specification sheets, I can then derive whether this is a constant current or a constant voltage. Typically only tape lights and similar fixtures are constant voltage predominantly. Most fixtures are constant current. The difference is constant current is we will actually push the power into the fixture, whereas a constant voltage, it will pull what it needs. But all of this is low voltage, less than 48 volts. The reflected ceiling plan, essentially what you're going to do is have or create or, you know, ask me and I'll send you symbols that you're essentially going to overlay on top of the drawing, which will ultimately give you the counts. But incorporated into that will also be things like how many drivers do we need, how many PoE switches do we need, and wall switches. The benefit of having all of this networked is, for example, I can have a wall switch connect to any PoE driver and then use the network to route that wherever I want. It doesn't have to be connected to the light fixtures in a given room. So I can have a wall switch in one room attached to the network, control fixtures in a completely different room. And that goes to the flexibility. So if somebody says, hey, can I have an extra wall switch? The installer can literally hook it up anywhere in the network, and then software will route it where it needs to go and control the group that it needs to control. So that's an example of the flexibility that PoE systems provide. This is one of my focal points in terms of just the hygiene of a PoE design is because now every fixture can be individually controllable, I'd like to have some kind of formula for what each fixture's unique identifier name will be. And I typically focus on room number underscore output wire number underscore last four digits of the MAC address. Why? Essentially, I want to integrate and tie together the reflected ceiling plan, the physical installation and wiring, and the virtual address. We can create a friendly name if you want something that's, you know, less difficult, but essentially what I'm doing together here is creating the as-builts directly up front. So by having the room number, the output wire number, and the MAC address as part of the unique name, then I've essentially bound together those three worlds. And then you can give emergency fixtures a different prefix, and then go into adding sensors. You can, again, have sensors have a unique name. So again, room number, input wire number, MAC address. And then from there, essentially, you're going to create the bill of materials. So essentially, that comes, you know, directly out of Bluebeam. You can export those. So for example, I just export the CSV file. I then import them into my Excel, and from that, I can essentially then create the load calculations. So load calculations are basically, I know that I'm not going past my 90 watt per port limit, and that I don't have any issues. I have this spreadsheet. I don't expect you to memorize or capture this. I'm morally just, you know, offering this as a example of one of the things you can do with PoE lighting is do the full load calculations, identify any issues or concerns, and then emergency power, how much power do I need for my emergency lights, and then essentially you can have any battery backup or emergency plans to support that. And then ultimately do your counts, and then same thing for the inputs, just essentially export the inputs. You're going to create groups. So one of the things that PoE also does is it allows you to abstract away technology. So by that I mean, by creating groups of fixtures, groups of inputs, the elements of those groups can be different technologies. So I can have a wall switch simultaneously control a DMX fixture, a PoE fixture, a high voltage fixture, a dolly fixture, and a phased in fixture. So the opportunity with software is essentially you can allow technology to migrate underneath, but not perturbate or disrupt the operations of the building. Okay, and then I know I always get a bunch of other questions like plug load. How do we handle plug load? Essentially, this looks the same as an on-off fixture, and then just has a high voltage interface. Code compliance we do all in software. So for example, California Title 24 requires auto off, manual on. Essentially in the software world, that just simply looks like ignoring the occupancy event and letting the manual wall switch then adjust the level. Daylighting, again, you can create different daylight zones, so zone 1, zone 2, zone 3, and you can go down to each fixture in terms of how it responds to a given daylight level. And then emergency lighting, I've got a couple of slides I can show there if people want to know how to do emergency lighting. We can do dynamic color tuning, so if you want to have the ability to adjust warm or cool, or even do circadian rhythms via schedule, we have examples of being able to do that. And then you can integrate different high voltage fixtures and pendants using a low voltage bulb. And that's an example of the emergency network, how the network is essentially integrated. So that's, I know, kind of a quick rundown. I can go into some more examples of different sites if you want to see the details and plans of those. But I want to open it up for questions. Anybody have any questions or feedback? If not, I'll hand it back to Damon.
Thanks, Joe. Yeah, hopefully this can just be an opportunity for other folks to just chime in and just have discussion time. So one of the questions I had is, you're talking about now we can go up to 90 watts per cable, but then it looks like there's another limiting factor. Was that on the driver of the 72 watts, or depending on technology? Yeah.
So I can't speak for every driver. A driver should be able to support 90 watts at the source. 72 comes if you have a 100-meter cable, which is 328 feet. You do have some line loss over the cable. Worst case scenario, that is 18 watts. So at 100 meters, the received power by the driver would be 72 watts. So the design would just have to incorporate that. And then it's linear in between. So if you know your max cable run length, then you can design accordingly. So very conservative would be 72. In most cases, 80 is pretty standard to what I designed to. And then if you're right close to the power supply, then you could do 90.
So if we go back to that slide that you showed of the conference room, and all the different fixtures there, how would you envision, you said, no conduit, which is great, so there's a lot of savings there. But are you going to need a different Ethernet cable for each of those different fixtures? Do you have two fixtures coming off of one? What does that kind of physically look like in terms of cable routing through the room?
So in this, you can see my slides?
Yep.
Yep. So in this case, I would have in the ceiling an 8-port switch. I would have 5 of these guys, so I would have 5 short Cat5 cables, and then I would run for anything that's monochromatic and 18.2 to each fixture. So 18 gauge wire is very common in sprinklers. To an RGBW, I would run 18.5. So you would have RGBW and then a common return, common anode. And then for these guys, again, I can just do 18.2. This is an example of it's essentially a quad driver, so it has 4 independent outputs. So it can handle up to 4 different fixtures. So in this case, I've got a total of 12 fixtures, and I can essentially do 4 per node per driver.
Okay, cool.
And then for RGBW, that is essentially consuming one whole one because it's 4 independent channels. For CCT, dynamic CCT, you could have 2 groups of fixtures per driver.
So looking at the economics of installing one of these, you know, we're going to need more drivers. You know, how much do those run? Are those prohibitively expensive? Are there savings since we're not using conduit, or safety factors since we're not dealing with high voltage? What does that look like?
So the biggest savings, I'm going to drag over another slide set here, if you don't mind. So in this case, you're going to have the savings of each fixture having a, so you subtract out the driver in each one of these fixtures, which is anywhere from $10 to $15. And then that now gets essentially incorporated here. So call this under $200. So yes, that is more expensive. However, the savings are overwhelmingly substantive in the what I call the Dragalong cost. So with high voltage, you need essentially 12.5 wire if you're going to dim everything independently, and you need conduit. So I just have this example of a high voltage where average cost of $50 a fixture versus low voltage, even if it's $125 a fixture, because the driver is a little bit more. It's the drag-along cost that you avoid. That today, it's literally 6.5 times more expensive to install the fixture than the fixture is actually worth. What low voltage technology does, PoE here specifically, it literally brings the installation cost down to half of the product cost. And yes, I've got a difference in product cost, but essentially the concepts, what the technology brings to bear is the infrastructure behind the fixture you don't need anymore. And that's that's the conversation that needs to change, because it's not just about the product cost, it's about how much it costs to get that product in the ceiling.
This is really helpful. Thanks for sharing this. Yeah.
Mm-hmm.
So hi, Joe.
Yep.
Chris Polo from Idaho Power. So thanks a lot for your presentation today. I really dig this stuff. I think it's cool and can't wait to see more and more of it. One thing from a utility perspective, that ability to avoid the AC-DC conversion, that's particularly compelling for me. Are you familiar with any studies that kind of quantify like the losses we're avoiding, or any kind of dollar stuff, or any stuff off the top of your head around that particular aspect?
I was talking with a friend of mine who's at the DOE, and that was one of the things that I was kind of kicking him in the head about, is getting a more significant study. Pacific Northwest National Labs has released a report talking to this. It's not as conclusive as I would like, but they did actually kind of push down. I'd be happy to send you the paper, but if you just search up Pacific Northwest National Labs, they did look at the DC and the DC microgrid. I fundamentally support the thesis that everything above the desktop can go low voltage, and doing things like USB-C, which is becoming much more prolific, it just makes so much more sense. What a lot of people don't know is that the light bulb becomes much less efficient when it dims. So a lot of cheap, lighting has been designed for cheap and inexpensive versus efficient. So a lot of light fixtures, when they dim down, actually just cast off a lot of the energy in the form of heat. So they'll dim the light, but essentially are just still consuming a lot more energy than they should So it's not a linear response of 50% and consuming 50% power. It's actually much worse. So in the DC world, we avoid all that conversion, but we also have a much more efficient driver. Sorry, I probably went overboard on that, but.
Thanks for your thoughts. Appreciate it, Joe.
Mm-hmm.
Can you speak to the durability of these Cat5, Cat6 cables versus traditional technology?
Yeah, so the resilience of Cat5, Cat6 is exceptionally good. There's no major concerns in terms of the cabling. So I have seen some studies by UL. If you're going to push this in a pipe of any significant length, don't fill it more than 50%. So just to make sure that there's thermal expression. But the number one failure component, especially in lighting, is the driver. So the LEDs will last 10 to 20 years. It's the driver that fails. And the reason why the driver fails is it has in the interest of cost savings, an electrolytic capacitor. That electrolytic capacitor, especially any cheaper ones, does not survive transients in the AC domain very well. So you can have, 5K, 10K surges, and over 3 to 5 years, those electrolytic capacitors break down, and thus the driver fails. So if it's all DC, you have substantially improved the warranty and lifetime of the LED fixture by not having to go in the ceiling and replace the driver. No one goes and replaces the LED string, but a typical driver will last 3 to 5 years. You can get more resilient ceramic ones that were, 10 years, and I know utilities or outdoor applications often ask for them, but fundamentally by making it all low voltage and DC, you have essentially removed the number one failure inducer, which is electric surges on the AC wires, often coming about from just motors. Somebody opens up a refrigerator, causes a surge, and everybody downstream has to deal with it. So by removing all of that, we also make the system just more stable and more reliable. We get precision level dimming, so I can do sub 1% level dimming that you typically can't do with phase dimming or 0 to 10.
Thanks, appreciate that.
Sorry, I'll give you one more anecdotal. There is, talk about one site here. So if you can see this, this is a site that we just did in Dallas. 100% of these lights are all low voltage, and LEDs have gotten so efficient. The number one complaint with LED retrofit and upgrades is that they're too bright. And so on this site, we literally have everything ceiling trimmed to 60%. And every one of those fixtures, you can see, is plenty bright in there. We actually have the average power per square foot down to 1/10 of a watt per square foot. So this is an example of where just having the ability to do ceiling trims on a per fixture by fixture basis, tap into additional energy savings. This all can tie in with utilities in terms of load shed response. So literally I can have utility send me a web call that says, I need you to load shed 20%. I can immediately load shed 20% and do it in a manner that's invisible to the occupants of the space. So this, because it's all PoE based and web based, it essentially has immediate connections to utilities and or other load sharing, load response paradigms that make just energy consumption much more efficient.
That's really remarkable. It's great to have a visual of what these actually look like. So just you know, thinking very basically, you know, an old incandescent light bulb, you don't really see like an Ethernet port on there. So you talked about PoE ready lighting versus
Yep.
a bypass. Could you talk through that a little bit?
Yeah, so what most people don't realize is that every single fixture that was high voltage I can get in low voltage. This is a low voltage 25 watt A19 bulb. You can see different cord bulbs, fixtures that are, you know, that aesthetically look high voltage I can get in low voltage. So all of those wires just have an 18.2 running to it, coming off of a cable tray running down the spine of the building. So that cable tray is just hosting the Cat cable and the drivers, and then running out from that is just an 18 gauge wire to each one of those fixtures. And then it can be an A19, so if you have a favorite pendant for the architects, you know, you can have a sconce or a pendant that has an A19 socket, and I can do it in low voltage and dim it. And if you need more power, we can get, you know, different fixtures of different types, and whether it's bulb-based or integrated LED-based, it's just, you know, 18.2 if it's monochromatic, 18.4 if it's dynamic CCT.
Okay. So have you been exclusively focusing on LEDs because they're so, you know, such a low power draw, or have you looked at, you know, fluorescents like T5s, some of the newer generation fluorescents?
We can support high voltage, and we do support high voltage. So PoE, because of its 90 watt limit, obviously is not going to hit applications like warehouse and outdoor. So we do have, for example, a lighting control panel that does 120, 277, you know, 20 amp, either phase or relay dim. So we can support traditional and then integrate it into the same system, which is great because eventually if you want to change it out, it doesn't change the user experience. The fluorescence, so I know there's a lot of people that just want to take out a fluorescent bulb and replace it with an LED bulb. In many instances, that may be the simplest, fastest, most energy efficient model you could do. So if you don't have, you know, the walls coming off or the ceilings coming open, and you have a bunch of fluorescents, and you only just want to save money, you don't need new features, you don't do PoE. Just literally just take out the fluorescent bulb, screw in an LED bulb, and use just on-off. Fundamentally, you can't dim fluorescence, and by extension, you can't dim an LED that replaces a fluorescent. So that's often where the number one complaint comes in, is like, these are just too bright. I don't have a way to control it. So one of the things that we actually support is a contractor kit where you've got an LED fixture, and instead of replacing the fluorescent bulb, just add in a 2x2 LED panel next to it, and then just don't turn on the fluorescent fixtures. So you can add in PoE infrastructure next to existing infrastructure and get your savings just by not turning on the traditional wall switch that controls the fluorescence. Does that make sense?
Yeah, thank you.
So it's just a kit that you can essentially walk into a room. It's standalone, no programming required. It works off low voltage, so you don't need conduit, you don't need class 1 labor, but essentially install it adjacent to your existing lighting, and then you just can now dim and get LED savings versus a, And the other thing that I found with fluorescence, if a fluorescent is more than 2 years old, it's at the 30% of its original illumination level. So a lot of times, people are acclimating to a much darker level than when it was originally installed. And you can see behind me, I keep all my lights off. I've got enough light from my 2 monitors and my desktop. So for me, I actually, for the most part, never have my lights on. Right? I can turn them on. It gets god-awful bright in here. You can see them dim up and down, all of that. But those are examples of, I use this as a testing laboratory as much as anything else. But fundamentally, by default, I don't have the lights
on. A question came in from Chris Paulo that Wi-Fi or wireless charging has really been getting increased attention for sensors, cameras, small motors. How do you see that technology either competing with or supporting Power over Ethernet?
I believe it can support Power over Ethernet. So one of the focuses of our platform is not to be about technology. So and this is just a philosophical opinion, I fundamentally believe that we should be bringing the technology to where the market is as opposed to trying to bring customers to where the technology is. So by that I mean we shouldn't be fighting wars of Bluetooth versus PoE versus Dolly or Zigbee. So we've fundamentally designed a platform that does all of them. Each has merit and benefit. So wireless often has the benefit of just being installer friendly. It's easy. Its limitation is you got to change the battery. So a wireless Bluetooth sensor, most people don't realize, will not participate in the mesh. It is essentially an input to the mesh, but it doesn't repeat and forward messages in the mesh. So unless you have Bluetooth in each fixture, a wireless Bluetooth sensor is not very useful in and of itself. It's only useful if you also have wired, powered Bluetooth repeaters in that network. So that's good. We fundamentally like PoE because one, it's secure. You don't have wireless hacks that can occur. And most people associate hacks with getting in and changing the state of your lights. I actually look at denial of service, somebody coming in and putting an arbitrarily loud signal as a much more credible threat. Wired just works well in schools, government, where you can't have wireless. But fundamentally, we don't care. I'll take, and this you saw, this is an Ocean sensor. There's no wires, no batteries. I like it because I literally can put it anywhere I want. But we use that all the time. So it's less about the technology, it's more about the integration of the technology. Sorry, I know that was a long answer.
That's great. That's great. This is a fun discussion for me. Actually had a grad student here in the room. Chase, did you want to ask your question? Kind of, because you were starting to touch on.
Yeah, you were kind of starting to touch on kind of cybersecurity issues. I guess what, in kind of a more general sense, would you kind of say for people concerned about cybersecurity in trying to integrate this technology within their buildings?
Mm-hmm. So, I mean, there's, security, I think, often falls into two major categories, wired versus wireless. So, wireless, you have two types of attacks. The easiest is a denial of service, and the second is someone actually getting into it and breaking through the security. The latter one is really, really difficult to do. I mean, you know, it's all encrypted. There's a lot of technology that goes into preventing someone from getting into, you know, a system through what I call the front door. The denial of service, I think, is actually more of a problem. It may be accidental. So, for example, if somebody inadvertently adds a wireless access point right next to a Bluetooth, you know, transmitter, they've basically drowned out that Bluetooth's ability to communicate just by cohabitating 2.4 gigahertz spectrum. So, I mean, those are things. Wireless is just hard to also look at the obstruction issues that can occur, especially if you're changing walls. But in terms of just raw hacking, it's pretty well encrypted and, you know, has the standards that you use when you're doing banking transactions. In terms of wired, inherently it's more secure in that it's not accessible. So the only real way to get into a wired network is you have to have a physical key into the network closet in order to get into the system. So it's essentially no less secure than someone who has access to the electrical closet who can go in and flip your breaker. So in terms of threat perspectives, the wired only paradigm essentially is as safe as traditional models of, you know, having access to an electrical closet is really the only way you can get in and hack it. Did that answer your question, or were you looking for different?
That does a really good job of just kind of explaining how, just the security aspects of it. Thank you.
Mm-hmm.
I'm going to go ahead and launch, or maybe Jason can launch the poll for our attendees, just so we capture, future topics you'd like us to cover. But that does not in any way preclude questions. I know I've been hogging the Q&A time, so if others have thoughts or questions, please unmute yourself and ask Joe while we've got them. You can also type them into the chat if you want as well.
Sure. So I had a quick question for you.
Yeah.
So you mentioned earlier that the piece of the system that needs to be replaced, I think you said 3 to 5 years, is the driver system. What kind of parallels can we draw between replacing those drivers and, traditionally replacing a light bulb? A light bulb, you can see when it needs to be when replaced, it explodes. How can you tell that a driver needs to be replaced?
The light doesn't turn on, so they fail off. So a LED fixture that has a driver that's essentially died, they will fail in the off state. So unlike a light bulb where, it's, someone should double check me on this, but I think the failure rate is to the order of the 5th power of the voltage. So if your voltage is running low, the life expectancy of your incandescent is pretty long. If it's running high, you can shorten the life of your incandescent pretty quickly. Fluorescents have a ballast, and that ballast, again, still has to convert AC power into essentially a voltage that will essentially conduct an arc across the gases. And that's not an easy, design. That's, challenging, but it still has to deal with surges on the front side. So by making everything low voltage, you've essentially taken the transients out of the system that are the #1 failure component in any of those situations. So, whether it's a light bulb suffering a transient, a fluorescent suffering a transient, by removing that, you've substantially enhanced the stability of your system.
Awesome. Thank you.
Mm-hmm.
On the safety side of things, I mean, this is low voltage, which is great. So there's, less maybe security or precautions needed. But I'm assuming it's not wise to take a pair of scissors to one of these cables. What is like the consumer experience with power over Ethernet?
You absolutely can take a pair of scissors to this.
Oh, wow.
So you can literally, we have a video if you want to afford it, but you can literally, I can take a live wire, stick it in a glass of water, swirl it around, and then dry it off, plug it back in, and the light works. So it's literally that safe. Because it can't penetrate the resistance of your skin, it doesn't create any electrical shock.
Wow.
And so National Electric Code 2020 officially lists anything less than 60 volts as low voltage, and essentially that's what it's working around, is that it can't penetrate your skin and arc through and cause electrical circuitry, your nerves essentially, to pick up the signal. Yeah, so literally you can take a pair of scissors to it, you can stick it in water. That's why I'm personally very excited about it, is you don't have kids anymore. Like, imagine, I as a kid, I actually can speak from experience. I as a kid took a bobby pin and stuck it in an electrical outlet and, literally caused a flash and a spark and a nasty event for my parents. So.
A lot of potential with this technology. It's pretty exciting.
Yeah. Yeah, and we've seen. I mean, it's been great to see a lot of the unanticipated serendipities, like change order requests. To do it in high voltage, $27,000. To do it in low voltage, $0. Things like that. Where it's like, wow, didn't even think about them. sustainability, right? Less copper, less steel.
Yeah, plus the controls. I mean, we just, in our office, for anybody that's online that wants to see them, we now have luminaire level lighting controls installed. Dylan just reconfigured them yesterday, so as I was walking down the corridor, one light like lit up right after the other. It made me feel super powerful and important. It was great. You know, but that was, you know, that was a big cost of install to get the electrician into the building to do all of that. And with Power over Ethernet, it sounds like, you know, you can address, you know, each fixture individually and start doing some of this control at the individual fixture level.
Mm-hmm. All right.
Well, any last questions? Could open for another
Okay.
awkward 30